All right, back here again, section 6.3, and I kind of zoomed through some questions here to get to some that have some data. So sometimes we're given the results and sometimes we have the raw data to look at. So on this one it says you wish to test the following claim at a significance level of alpha equals 0.002, which I guess technically is what, 2,000ths? For the context of this problem, we have this just kind of given our stuff. Our null hypothesis is that the difference is 0. Our alternate hypothesis is that it is less than 0, the mean of our differences. And the important takeaway so far is we have a left-tailed test. Now, you believe the population difference of the scores is normally distributed, but you do not know the standard deviation. You obtain the following sample data. So here we have sample data, and then we need to find a test statistic, a p-value, make a decision, and all that fun stuff. So we'll grab our data set and copy it. We come over here, and I'm going to just give myself a little bit of space, and I do like to paste special if it will work. And notice here, I got this data set here. My count is 24. So for this one, I've got n is 24. And then I sort of need to find some stuff. I'm interested in the differences. And so here's my post-test and my pre-test. So the difference is going to be the post-test minus the pretest. You got to make sure you do this correctly. Sometimes they're listed in a different order, so just kind of pay attention there. And this is the differences. So now that x bar sub d is the mean of the differences, and the mean in Excel, it really likes the average function. Grab the average, grab the data set, and there we have it. And then we also want S sub d, which is the standard deviation of the differences. Again, we're dealing with a sample here, so this is the standard deviation of the sample. We're trying to make inferences about the population, but we're using this stuff here. So if we don't have the numbers, we've got to find them first. Now we've got x bar sub d, we've got S sub d. I guess I could go for the degrees of freedom here, which is n minus 1. And you'll notice here, since this is matched pairs, we're talking about before and after, and that's why our n is 24, not the sum of the whole data set. So just kind of pay attention to some of those kinds of things. Okay, so we have our null and alternate hypothesis. I really like to wait to draw the picture until I have my test statistic. To find my test statistic, I need the standard error, which is going to be the standard deviation of the sample differences divided by the square root of n. And then I get my test stat here. And it's going to be x bar sub d divided by the standard error, because we already kind of have that differences taken care of. Now I probably should have known, since I have a negative value and this is going to be positive, that we were dealing with a negative test statistic, but now I kind of feel like it's a better time to draw the picture. So here it goes, a little picture. Negative 1.6 would be somewhere over here. And that is our test statistic. Oops. This is left-tailed, so I'm just looking for the area right here. Oops, kind of a little over, but that's okay. You get the idea here. So the p-value is going to be a t-distribution, and I use my test statistic, and then the degrees of freedom. And then true gets me the area to the left of that value. Now notice I want 4 decimal places here, and I've got 0622. It probably is rounded. If I want to just roll it over a little bit, 198, so we're kind of okay here. What is the test statistic for the sample? Report your answer accurate to 3 decimal places. So I've got negative 1.59, and then there's a 4 followed by an 8, so that's going to round up. And again, our p-value 0.0062, and then 1 followed by a 9. That 1's going to go to a 2, so here we are. Now making a comparison of this value, our p-value, to alpha. We are greater than alpha, our p-value is, and so there is not going to be enough. We're going to fail to reject the null hypothesis here. So again, working this one out, we had data sets given to us, so we had to figure out the differences. Make sure you do the post-test minus the pre-test. The order is not always the same on these, and then use that data set to find our sample size. Again, we're interested, since they're paired data, before and after. We count up just one side for the n, and then we find those differences. Find the mean of the differences using the average function. Find the standard deviation. Use the standard deviation of the sample function. Degrees of freedom. Take 1 away from n. Our standard error is that standard deviation divided by the square root of n. And then our test statistics, since we don't really have our difference is always 0. We're going to say there is no difference. Is often the null hypothesis. So it just becomes our x bar sub d divided by the standard error, and then we use our functions here to find the correct area with our p-value. So again, another example worked through, problem number 7. So we've got one where we're given data, and then where we have a data set and we have to do a little bit of calculating. One thing you'll notice, there are kind of lots of types of questions here. If you feel really confident that you've got it, feel free to skip around. You will miss a few points. You can also kind of copy and paste these and sort of updates the things. But just remember, on the exam, you're going to be expected to start with nothing and work it out. And then you want to make sure you're prepared, whether it's left-tailed, right-tailed, or two-tailed. But there are no more tricks or surprises here, just some practice problems for you. So I'll probably do another video with another example, but feel free to get started on the section work if you feel like you've got it now.